Hello friends, myself Dr. Gurraj Singh, and in today's video we are going to discuss a very important topic, that is on the comparison of TIG welding with MIG welding. So these are two very important arc welding techniques, the first being tungsten inert gas welding and the second being metal inert gas welding. So we'll just have a look at the key differences between the two. So this image here clearly represents the two techniques. On to the left, as you can see, is the MIG welding technique, and on to the right we have the TIG welding technique. Now how can you identify this? By just looking at this image. First of all, you have got this wire feed mechanism in case of MIG welding, and we all know that there's no wire being fed in case of TIG welding because we have a fixed tungsten electrode. Second key difference is in the filler metal. So you do not need a filler metal separately in case of MIG welding because the wire itself is being fed to the welding zone, into the arc, into the weld pool, and it itself is acting as the filler metal. On the other hand, the tungsten electrode, being non-consumable, requires a separate filler metal, as you can see this rod, which needs to be added so that we can influence the properties of the weld. Next, this slide, now it clearly shows the other differences. Now first of all, if you take a look at the direction of welding, we are welding in this direction, to the left, for both these cases. So on the left you have your TIG welding torch, on the right you have your MIG welding torch. Now you can clearly see that the angle at which you are moving your torch to the direction of movement is different for both these cases. It is an acute angle for TIG welding, that is, it is less than 90 degrees, but it is obtuse for MIG welding. So that's how it's kept while performing both the welds. Secondly, you can have a look at the difference in the standoff distances. In case of the tungsten electrode for TIG welding, you're maintaining a small standoff distance for the arc to be struck, which is not there in case of MIG welding. The third key difference exists in the type of polarity that you're using. So in case of your TIG welding, the polarity is T, C, E, N, direct current electrode negative. And in case of MIG welding, the polarity is D, C, E, P, direct current electrode positive. Now how can you identify this? It's very easy to memorize because in case of TIG welding, you're connecting your TIG torch to the negative electrode of the power source, while the workpiece is being connected to the positive electrode. So when your electrode is being connected to the negative terminal, it is electrode negative, and that is why we're calling it as direct current electrode negative. But it is also called as straight polarity, right? So you can either call it direct current electrode negative, or you can call it as straight polarity. On the other hand, in case of your MIG welding, you're calling it as DCEP because your electrode is connected to the positive terminal of the power source, and the workpiece is connected to the negative terminal, that is the cathode. So when your workpiece is connected to the cathode and your torch is connected to the anode, you call it as direct current electrode positive polarity, and it is also called as reverse polarity. So reverse polarity, and this one is called as straight polarity. So these are the two basic differences between these two techniques. And also I've shown both the torches here. Now it is very easy to differentiate between the two practically as well, because the torch to the left, the one with the pink knob, this is the TIG torch, and the one to the right is the MIG torch. So they're usually in this shape. TIG torch has this kind of shape because this portion is used for holding the electrode, the tungsten electrode. While in case of your MIG torch, there's a continuous wire that is being fed, and therefore it has this bent shape to keep the movement of the wire on. So now we'll take a look at some of the key differences here, theoretically. So first of all, in case of MIG welding, it utilizes a consumable electrode. So that's the key point here. It uses a consumable electrode, while a TIG welding, it uses non-consumable electrode. Secondly, the electrode melts down to supply the needed filler metal and fill the gap between two pieces of the base metal. On the other hand, in case of your TIG welding, the filler metal does not melt, and instead you need to supply a separate filler metal. In case of your MIG welding, the electrode metal composition is selected on the basis of the parent metal, that is the metal that is being welded. But in case of TIG welding, it is always made up of tungsten. So you can have different material electrodes in case of MIG welding, but for TIG welding, it will always be tungsten. And therefore, the fourth point is basically a conclusion of the third point, that it is suitable for homogeneous welding. Now we know that homogeneous welding is that welding where the base metal and the electrode metal are same, and that is exactly what we've mentioned in the third point. And in case of TIG welding, it is particularly suitable for autogeneous mode of welding. Now what is autogeneous mode? Autogeneous mode is where you do not need a filler metal, where you weld without using a filler metal, simply by melting the parent metals together and then allowing them to cool down and form the bond. Alright, so next, the electrode cum filler for the MIG welding comes in the form of a small diameter rod, which is having a diameter of 0.5 to 2 mm. So it's a very thin rod. It's not rather a rod, it's a wire, and it's very long, several hundred meters long. The wire spool can be, because it's being continuously fed. It is a consumable electrode. But in case of TIG welding, the welding electrode is of a diameter which is from 1 to 3 mm, but it has a short length of 60 to 180 mm. So why? Because it is not being fed here, it is not being consumed. Secondly, due to a very large length, the filler electrode can be fed for a longer duration without replacement. But on the contrary, due to the short length, frequent replacement is required for the tungsten electrode. And that is the reason why we maintain a DCEN polarity, because the anode, it has a higher temperature, and therefore, it heats up the electrode. So when we keep it at the cathode, as we do in case of TIG welding, it prevents the electrode from heating up, and therefore tries to slow down the time for the damage to take place. So it basically takes longer time for the damage to take place, and you can replace it less often as compared to what you would be doing if you connect it to the anode. The MIG welding is commonly carried out either in AC or in DCEP polarity, so that we've already discussed. So you can also use AC polarity. Now in case of AC polarity, what will happen? After every specific time period, which is very short, a few milliseconds, your polarity will change. It will switch between DCEP and DCEN, because that's what happens in case of AC. It has this kind of a movement. It's a sinusoidal wave. But in DC, we have a straight line. So the polarity will consistently change between DCEP and DCEN in case of your AC current. In TIG welding, we can either carry it out using AC or the DCEN polarity. The filler deposition rates, now if we talk about them, they are very high in case of your MIG welding technique. Why? Because we connected it to the positive electrode. It has a higher temperature. It can easily melt the electrode. So you have better deposition rates and you have a higher productivity. On the other hand, the filler deposition rate is low here in case of TIG, because it is connected to the negative electrode, and in this sense, now I've mentioned in this sense, in which sense? In sense of being productive, it is less productive. But if you take a look at the quality of weld, it will be much better in case of your TIG welding approach. So thank you so much. We'll see you in another video. Bye.